Hi everyone, for this video we're going to discuss some special trigonometric limits. So the first one is the limit of sine theta over theta as theta approaches 0 is equal to 1, and limit of cosine theta minus 1 over theta as theta approaches 0 is equal to 0. This also can be expressed as the limit of x over sine x as x approaches 0 is equal to 1. And for the other one, we can also express this as the limit of 1 minus cosine x over x as x approaches 0 is still equal to 0. So let's try to evaluate these limits, special limits. So let's start evaluating the limit of sine x over x as x approaches 0 is equal to 1. So by substitution, this will be equal to sine 0 over 0. And sine 0 is 0, so we'll have 0 over 0. So if we get 0 over 0, then therefore this is indeterminate. And if it's indeterminate, from our previous lessons, we know that the limit does. So let's check this further by constructing the left and right hand limit. So let's start with the limit of sine x over x as x approaches 0 from the left side. So what we can do is we construct a table. So let's say, from the left of 0, so we have negative 1, negative 0.5, negative 0.1, negative 0.01. Okay, using our calculator. So sine of negative 1 over negative 1 will be 0.8414. For negative 0.5, it will be 0.9589. And the third one is 0.9983. And this one is 0.9998. So this approaches to 1. Next, let's do the limit on the right hand side. So sine x over x as x approaches 0 from the right. So once again, construct a table. So from the right we have 1, 0.5, 0.1, 0.01. So let's get our calculator to evaluate this. And by doing that, we'll get 0.8414, 0.9589. This is 0.9983 and 0.9998. So again, this is also equal to 1. Therefore, the limit of sine x over x as x approaches 0 is equal to 1. Okay, the next one, let's evaluate the limit of 1 minus cosine x over x as x approaches 0 and why that is equal to 0. Okay, so by substitution, okay, so we'll get the limit of 1 minus cosine 0 over 0 as x approaches 0 So this will be 1 minus 1 over 0. So we'll get again 0 over 0. So this is indeterminate, and therefore the limit does not exist. And the reason this is one of the special trig limits is because even if it's indeterminate and it does not exist, but there is actually a value, and that is equal to 0. So let's prove that. So how to prove this is by constructing a table wherein we will get the left hand and right hand side limit. So let's start with the left hand limit. So the limit of 1 minus cosine x over x as x approaches 0 negative. So let's construct a table. So we can start from negative 1, negative 0.5, negative 0.1, and this time let's have negative 0.001. Okay, so for negative 1, if we substitute, we'll get negative 0.4597. For negative 0.5, we'll have negative 0.2448. For negative 0.1, we'll have negative 0.04996. For negative 0.001, we'll have negative 0.000499. So this is approaching 0. Okay, now let's do the right hand side. So the limit of 1 minus cosine x over x as x approaches 0 positive. So let's see if this will be approaching 0. So let's construct again a table, and let's start with 1. We have 0.5, 0.1, and 0.001. Alright, so for 1 minus cosine 1 over 1, we'll get 0.4597. For positive 0.5, we have 0.2448. For 0.1, we have 0.04996. And for 0.001, we have 0.000499. So from here, from the table, we can say that the limit as x approaches 0 from the right hand is equal to 0. So therefore, the limit of 1 minus cosine x over x as x approaches 0 is equal to 0. Let's do some more examples with this special limits. So let's try this one. Evaluate the limit of sine x over x plus 3 as x approaches to 0. Alright, so for using the special trig limit, we know that sine x over x is equal to 1. Right? So the limit of sine x over x is equal to 1. So therefore, this is 1 plus 3. So the answer is 4. Second example, evaluate the limit of 1 minus cosine squared x over x as x approaches to 0. So how can we use the special trig limits here when we have the cosine squared over here? So as you can see, it's 1 minus cosine squared, so we can factor this out into the limit of 1 minus cosine x times 1 plus cosine x. Remember the difference of two squares? When you have a squared minus b squared, so this is equal to a minus b times a plus b. So that's what we did over here. Okay, so let's continue. So we have over x. All right, so as you can see, we now have the special trig limit. So 1 minus cosine x over x, this is equal to 0. Okay, so we'll have the limit of x as approaches 0. So we have 0 times 1 plus cosine 0. So let's substitute already. So we'll have 0 times 1 plus cosine 0 is 1. So 0 times 2 is equal to 0. So the answer here, the limit of 1 minus cosine squared x over x as x approaches to 0 is equal to 0. Okay, let's have some more examples. Next, evaluate limit of sine 2x over x as x approaches 0. So when we look at the problem, it's similar to our special trig limits of sine x over x, which is equal to 1. But the problem is we have 2x instead of just x. So we can manipulate this by multiplying the numerator and our denominator by 2 over 2. Okay, so we will have the limit of 2 times sine 2x over 2x. Okay, but we have sine x over x, and now we have 2x over 2x. So we can do is we let or represent this 2x with a single variable. So let y is equal to 2x. Okay, so we can change this also to y approaches 0. So what we will have is 2 times sine y over y. All right, so sine y over y, the limit, we know that this is equal to 1. So now we end up with the limit of 2 times 1. Okay, so now we can change this back to the limit of x approaches 0. So we have 2 times 1, or 2 times 1 is 2. So the answer, the limit of 2 as x approaches 0 is 2. Okay, another similar problem. So find the limit of sine 7x over x as x approaches 0. So again, we have a 7x instead of just x. So we again manipulate this by multiplying numerator and denominator by 7 over 7. So times 7 over 7. Okay, so we'll end up with limit of 7 times sine 7x over 7x. And then we represent 7x with a variable, single variable. So let 7x equals y. So we'll have the limit of 7 times sine y over y. And for the meantime, we can change it to y approaches 0. So this we know, sine y over y is equal to 1. So the answer now is the limit. Let's change this back to x. So 7 times 1. So the answer is 7. Next, we have the limit of sine 2x over 3x as x approaches 0. So what we can do here is we can multiply or manipulate this by multiplying 2 over 2. So we will have 2 times sine 2x over, so we can exchange this. So we put 3 over here times 2x. It's the same. Okay? So now we have sine 2x over 2x. So again, let 2x equal to a single variable y. So we have the limit of 2/3 times sine y over y. Okay, so since we use y, let's just change this to y. And then simplifying this, which is we know is equal to 1 by special trig limits. So we'll have 1 times 2/3 or 2/3 times 1. So the answer is 2/3. Next, we have the limit of sine x times the quantity 1 minus cosine x all over 2x times x as x approaches 0. So from here, we can see that we can separate this from this by multiplication. Okay, so we can rewrite this as the limit of sine x over 2x times 1 minus cosine x over x. Okay, so this sine x over x, we know that this is a special trigonometric limit, and then we can remove 1/2, so we can have 1/2 times sine x over x times 1 minus cosine x over x. Okay, so let's evaluate what we know. So sine x over x is equal to 1, and 1 minus cosine x over x is equal to 0, knowing our special trig limits. Okay, so we have 1/2 times 1 times 0. So the answer is 0. Alright, last example. Find the limit of tangent x over x as x approaches 0. So we have tangent x over x, but we only know sine x over x. But we also know that tangent x is equal to sine x over cosine x. So let's do that with our given. So tangent x is sine x over cosine x times 1 over x. This is this one, our x in the denominator. Okay, and sine x over cosine x is our tangent x. All right, and then look carefully what happened. So as you can see here, this sine x over x here is our special trig limit. So let's group that. So sine x over x times 1 over cosine x. So we know that sine x over x is equal to 1. Okay, so that's 1 times, what is 1 over cosine 0 by substitution? We know that cosine 0 is equal to 1. So 1 over 1 is equal to 1. So the answer, 1 times 1 is 1. That's all. Thank you.